Alright, check this out. I'll tell you a little bit about my theory of how the shape of the universe and how things work in it. You have the Big Bang, but pre-Big Bang, this singularity. A lot of people think that there was infinite amount of empty space and all the matter was condensed into this small point, and that you could see it explode from outside if you were out there. But my theory states that space consists of matter and spaces between matter. And before the Big Bang, there were no spaces between the matter. Therefore, there was no outer space. There was nothing outside of the matter.
There was no space between our atoms in our body.
There was no space anywhere. Therefore, there was only the singularity. The universe wasn't infinitely large. It was infinitely small. The matter and the space. And there was no time because there was no motion. And as soon as it started to expand, motion happened and time happened. So you have this ball, a sphere that's ever expanding. Inside of the sphere is the past. Outside of the sphere is the future. And the sphere is this bubble of the present time. So say we're here. Yeah, everything. That's where all the stars. It's like our 3D space right here exists on a 2D surface of this bubble.
It seems like it.
It's like we're characters on a TV screen. The TV screen is flat, but we can move in 3 dimensions in this flat TV screen. And so, say I'm on the surface of the present time, and I'm looking at a star way over here. I'm looking into the past, say it's 1,000 light years away. Well, light travels in a spiral, so when I look at the star, I'm actually looking at a spiral that looks inward, so I actually see the star down here. If you think about it, if the present time is on the surface of the ball, then in the center of the ball is where it all started. And in an arrow going straight outward, you have time. Going perfectly in a straight line at the same speed always. So the ball is growing with time. So when I look at the star way over here, I see it down here. So if I look far enough, I can see the beginnings of the universe. Likewise, if I travel the speed of light, you know what a light clock is? This is how general relativity works. You have a light clock, and it's 2 mirrors with a photon of light bouncing.
There is magic in the way it is created,
and it bounces back and forth at the speed of light. If I move this clock to the side,
beyond the magic
that
of light
photon of light now
itself,
has
there
to
is the
travel
magic
this
of
way.
science, finding new and amazing uses for light.
Mirrors slower. And if I'm with the clock, I see the
A
photon of
remarkable
light
new
moving
device
slower.
splits light into separate
If this
narrow
clock
rays
moves at
so that
speed
the
of light
path of a
to
beam
the
can
side,
easily be
that
followed.
photon will stop.
Notice that the light spreads out from its source in all
At the
directions.
speed of light. Therefore, time stops. That's why if
We can
light
see how
travels
a mirror reflects
at a
light.
spiral outwards, and sight, as I look at it, travels inwards. If I travel
Our
the speed of
prism
light
bends the rays in
around the
different
universe,
directions.
time will stop for me, and I will travel in a spiral going outwards into the future. Because time has stopped for me, but it moves for you. No, if I'm moving at the speed of time, time stops. If I look, I'm looking into the past, going inwards.
Yeah, because I can see how the light from the past still exists.
Yeah, it always
Where it
exists.
doesn't go anywhere.
It's like it's always traveling like this, around and around and around the universe.
Computer-driven data displays reveal the spacecraft's quickly changing location, velocity, and other conditions derived from tracking the spacecraft and communicating with the crew.
Roger, the S-band pointing is pitch minus 22, yaw plus 8.